Hey everybody, welcome back. Today we're going to start section 3 for Math 35, College Algebra here at College of the Sequoias. Section 3 is a review section. It's on polynomials. And in the review section, it goes by chapter R. So this is R3, and we're working with polynomials, which is a nice little word there. So in mathematics, terms are the product. Remember, product is the outcome of multiplication. So when we multiply two things together, we call that the product. Terms are the product of numbers and variables. And with possibly exponents involved. Okay. So we could have something like 3x plus 4. And another way of writing this would be, we have 3x plus 4. And although we haven't covered it yet, this is like 4x to the 0, and x with no exponent is like an x to the 1. And we'll cover the rules of that in a little bit. The number in front is called a coefficient or numerical coefficient. And a polynomial is one or more terms combined through addition or subtraction. That green pin's dead, we'll throw it away. For subtraction, as a rule of thumb, we use lowercase for variables. Is the norm. Lowercase letters, I should say, lowercase letters for variables is the norm, but any symbol can work. We discussed that last section, like smiley faces and stuff like that. And the reason why we have that, I put that x to the 0 in there. In 1 second, there's a fan on and I need to turn it off. The reason why I can put that x to the 0 in there is x to the 0 equals 1. So this is like 4 times 1, basically. We'll cover that more a little bit later. But it kind of reveals a pattern that we have. Some things with polynomials. So polynomials. Okay, so they no variables in the denominator. Denominator, or bottom of a fraction. No variable in the denominator also implies no negative exponents. We'll see that negative exponents lead to variables on the bottom in the near future. We said terms are separated by addition or subtraction. And some more terminology we have is like terms. It's really better off maybe calling them alike terms. Like terms have the same variables with the same exponents. So let me write down like a list of them and we'll show which ones match up. We've got 3x, 4x, y squared, z cubed. I've got 16y, 5/9 x, 7/2 y, and maybe 1/3 x, y squared, z cubed. Both this one and this one have just an x to the first power. So these are similar. I'll put like a capital A underneath them to show that they're related. But we normally don't have letters in them. It's just to show you that they're related. If I look at this one, do I have an x, y squared, z cubed anywhere else? Yes, I do. So these two are like terms. And then the next one, we've got y. This one just has a y. When there's no exponent, it's to the first power. So these two are like terms. So that's what we got going on there. Are you ready to see some more? I hope you hit pause if you need to. Another restriction we want to put on polynomials. Polynomials have a finite number of terms. Or a finite sum of terms. Sum is the outcome of addition. And with non-negative exponents on variables. So let's look at a few of them and see what we call them. First one we'll take a look at, 3x. When there's only one term, this is called a monomial. Mono means one. And I guess meal or something like it. Nomial is like one name or one term. I don't know. I don't speak Latin. I'm sure that's where it comes from. We could have 16z squared minus 9. Doesn't have to just be x's, any variable will work. Here I've got two terms. Just like a bicycle, bi means two. This is a binomial. So 2. I could have something like y squared plus 8y plus 16. Here there's 3 terms. And we call this 3 like a tricycle, trinomial. Tri means 3. We could have something like 4x cubed plus 9x squared minus 204x plus 1. There's 4 terms here. Guess what we call this? I kind of want to call it a quadrinomial, but at 4 more terms, they stop naming them. They shifted to just polynomials. As the name. And the reason why, poly means many. Okay. The number of terms matters. It's helped. I did say it was a finite sum. Recall, finite was a limited number, limited or fixed amount of terms. And the reason why they call monomial, binomial, and trinomial separate things, I think, I'm making an assumption here, I've never looked this up. The mathematics to work with monomials, binomials, and trinomials is much more simpler and easier to do by hand than working with things with x cubed and higher. Generally, when we have just a couple terms, we have something to the second power at the biggest, but that's not necessarily true. Not necessarily true. Some more information. So we use the word degree. The degree of a term equals the sum of the exponent on the variables. Some of the exponents on variables. So a little example here, we got like I can have 3 to the 4th power, x to the 9th power. The 3 is not a variable, so we're going to ignore the 4. The degree here equals 9. Or we could have something like x squared y to the 5th. The degree here, 2 plus 5. The degree is 7. Recall if you see something like this, c d cubed. The degree here, even though there's no number showing on the c, this is 1 plus 3 equals 4. So missing exponents equal 1. If the exponent is absent, it equals 1. And a very similar reason to, we don't put 1 in front of objects, and we don't say we drove 1 car to work. It's assumed if you don't mention a quantity or a number, the number is 1. It just saves time and effort. Ready to go on? All right. So what kind of things can we do with polynomials? So operations with polynomials. Well, we can add or subtract them. We add or subtract polynomials by adding or subtracting, if that's the operation, the coefficients for like terms. So let's take a look at an example. Let's have we've got 3x to the 5th plus 4x cubed plus 9x squared plus x minus 1. And we're going to add that to another polynomial. Let's go with the 6x to the 6th. Oh, yeah, I like this. Minus 5x to the fifth power, plus, I'm just getting lazy here. My coefficients are deliberately matching my exponents for fun, minus x plus 1. So this is one polynomial, and this is another. I've got a lot of terms here, but I can add them up by matching terms, like terms, and adding their coefficients. When you have something like this where there's a lot of them, it helps to stack them. So I'm going to put down 3x to the, I'm going to stack these on top of each other. 3x to the 5th. The next number down from 5 would be 4. I don't have an x to the 4th, but I have an x to the 4th here. So I'm going to put 0x to the 4th. And hopefully it makes sense in a second. And then I've got 6x to the 6th minus 5x to the 5th plus 4x to the 4th minus 3x cubed plus 2x squared minus x plus 1. When I add these up, now I hopefully it's a little clearer. By putting in a 0x to the 4th, I have something to line the 4x to the 4th up with. And notice that those variables are the same with the same exponent, same exponent, same exponent. Exponent is 1, exponent is 0. 3, 4, 5, and exponent here is 6. I can just add them up. Nothing adds to the 6x to the 6th, so it stays the same. 3 minus 5 is negative 2, so I'm just looking at those two. 3 minus 5 is negative 2. 0 plus 4 is 4. 4 minus 3 is 1. 9 plus 2 is 11. X minus x, I'm literally writing down everything, and then I'll clean it up and write it how I would. But I want to make it clear what's going on. So x and negative x cancel out, negative 1 and 1 cancel out. If I were to write this, I would write 6x to the 6th minus 2x to the 5th plus 4x to the 4th. I would not write the 1, I would just write x cubed plus 11x squared. That would be the sum of those two polynomials. So let's take a look at maybe another one. Wait, what kind? What? I didn't mention it. So the degree of each of these terms, the degree of this one is 6, 5, 4, 3, 2, 1, and 0. And then when we talk about the degree of a polynomial, the degree of a polynomial is the highest degree of the terms. So in this case, the biggest degree is going to come from x to the 6th. This polynomial is 6th degree. Okay? Okay, I'm assuming you pause it. We'll go on, do another one, show another way to do this. You don't always have to stack them vertically. I did that because there was a lot of numbers. Let's do another example though, where there's less numbers, and I'll show you another approach you might like better. let's say we have 4x to the fourth minus 5y squared plus z. And I'm going to add, that's one polynomial. And then I'm going to add to it, I'll use a different color for the other polynomial so it's clear it's a different polynomial I'm adding to it. Let's add 6x to the fourth plus 4y cubed plus 3y squared minus 2z. One way to do it is to go through them and look at the ones that have, just start in one parentheses. I've got an x to the fourth here, so I need an x to the fourth. And I've got an x to the fourth here. So I'm going to take their coefficients and put them in parentheses in front. That's 4 plus 6 times x to the fourth. This is like factoring it out. Then I look at the next one. I got a y squared. I got a y squared here. So I've got negative, or I'm going to say plus negative 5 plus 3 y squared. Then I've got a z, and I've got a negative 2z here. I can do that. Plus, when no coefficients listed, we put a 1 in. 1 and negative 2z. And now I've done all the ones in there. Let's go to the last one that's unlisted. I gotta just put that somewhere. Plus 4y cubed. Then we clean it up. We add the numbers into parentheses. This is 10x to the fourth minus 2y squared minus 2z plus 4y cubed. What's the degree of this polynomial? The exponent with the highest term is the x to the fourth. That term's got a degree 4, so this is a fourth degree polynomial. And here I chose to have different variables. And when you do, sometimes you leave them in jumbled order like this. But when every term has the same variable, but with different exponents, we write or list them in descending order by exponent. Descending or decreasing. Descending order by exponent. Decreasing might be a better word. Descending is going downward, but it's more like something dropping in elevation. Decreasing means numbers going down. So whichever one you like. But to give an example, let's say we've got 7x squared minus 16 plus 2x cubed minus 5x to the fourth plus 1 x plus 11x. Let's make it plus 11x. The exponent, or they all have x's in them except one of them, but remember when there's no x, no variable, it's like x to the 0. So the biggest term is the 4. Make sure you take the sign in front of it with it. This is negative 5x to the fourth. The next one is 2x cubed. And then we've got 7x squared. There's no sign in front of it, means positive. We are adding it though, so we're going to say plus 7x squared. And then we've got plus 11x. And finally, minus 16. So we're going to rewrite like this. The biggest reason is when other people are looking at your work and using it, when we read left to right. So when we see that thing on the left having an x to the fourth, right away we know the power, the degree of this polynomial, and certain properties, certain ways we solve it are more useful that way. Ready for more? We covered adding and doing the decreasing. Let's take a look at subtracting polynomials. Like, let's say we've got negative 6m to the fourth power minus 12m squared plus 13. And I'm going to subtract m to the fourth minus 8m squared minus 11. Let's say plus 11. Say plus 11. This is easier to do. Rewrite the second polynomial as addition of the opposite signs. This is effectively like distributing a -1. So what I mean by this is I've got my first polynomial, negative 6m to the fourth. I've got no m cubed. I'm going to put that in just in case. Minus 12m squared. I've got no plain m. I'll put a 0m in there. Plus 13. Now I'm going to add the opposite sign. So everything that's in here, I'm going to change the sign. Change the sign. So m to the fourth becomes negative m to the fourth. Negative 8m squared becomes positive 8m squared. I'll line it up under the m squared terms. And 11 becomes negative 11. I'll line that up under the term with no variable. And we combine like terms here. Negative 6 plus negative 1. There's no number there, so it's a 1. Negative 6 plus negative 1 is negative 7. I'm not going to write the 0, 1 because we don't have anything. Negative 12 plus 8 is negative 4. We don't have any m's to the first power, so I'll leave them out. 13 minus 11 is 2. So that's the easier way right there. This is my pro tip. Rewrite as the opposite sign and then make an addition. Makes it a lot easier. Why don't we kick it up a notch? Let's kick it up a notch. Let's do 6 times z squared minus 5z plus 3. And from it, we're going to subtract. Let's do 5 times 3z squared minus 4z plus 6. Okay, so step 1, let's distribute. So 6 times z squared is 6z squared. 6 times negative 5z is negative 30z. We multiply the coefficients, multiply the numbers, and 6 times 3 is 18. I'm going to treat this as plus the negative 5 times that. So whatever I have here, I'm going to add. Negative 5 times 3 is negative 15. So I'm adding a negative number is subtracting. Negative 15z squared. Then I'll do negative 5 times negative 4. 2 negatives make a positive. So positive, and 5 times 4 is 20. And then negative 5 times 6 is negative 30. I'll now just go through, what I tend to do is I underline as I use them. That way I make sure I count them all up. So I look for my highest exponent, my biggest degree, looks like a square. So I've got a 6z squared and a negative 5z squared. 6 minus 5 is negative 9. Then I look for my next lowest term, which will be z to the first power, or just z. We've got negative 30z plus 20z. Negative 30 plus 20 is negative 10. And finally, I look for just the constants. 18 minus 30 is negative 12. And we call terms without variables constants. Constant. And it's a constant because it's not changing. It remains at the value. This always will stay at negative 12. Okay. Ready for more? I thought you might be. Let's take a look at rules for exponents. The rules of engagement. Rules for exponents. Pretty excited. I got to play D&D for all of like an hour. We're all doing background characters for a new campaign. Pretty excited. I don't have to DM, which means I get to just chill. I'm playing something called the Blood Elf. The Blood Elf is like a living vampire. This is pretty cool. I told everybody in open day I wanted, if I could be a vampire, I would. And check it out. I get to role play being a vampire. That's alive. It's living. It's not, vampires in stories are dead. This guy's, the blood elves in this story are creatures that just drink blood. They need blood to live. So I'm going to be one of those. Pretty exciting. I like role playing and playing games like that. This should be fun. So our first example, I'll just lead by example. Lead or explain by example. Where it comes from. So if I have 2 squared and I multiply it by 2 to the 5th power, the 2 squared right here, let's use colors. It's probably not, it'll do well in the video, but when I scan it, it's going to be black and white. The 2 squared is 2 times 2. Then I have this dot is that dot right there. And 2 to the 5th power, I'll do in green. We can expand that out as 5 2's multiplied together. That's what that means. Notice when all is said and done, how many 2's do I have? 1, 2, 3, 4, 5, 6, 7. I can write this as 2 to the 7th power. And if you notice, is there any relationship between the exponents I started with and the exponents I ended with? Right, there is. I hope everyone recognizes it. 2 plus 5 equals 7. So long as the bases are the same, when we multiply exponential terms, we add the exponents. That's me spelling it out in words. If I were to say it in words, and I just said it in words, the symbols they like to use is this. For integers m and n, a to the m power times a to the n power equals a to the m plus n. I don't even think I need the word integers. Let's say for m and n, I know fractions work. I can't think of numbers that don't work. For m and n being real numbers, I guess. Let's just say for m and n. That's our general rule of thumb. If we've got the base, notice the base is the same. We add exponents. That's our first rule, rule number 1. Let's say rule A. I'll lead by example on the next one. Let's do, we don't need to just do numbers. We can do variables. X cubed or x squared cubed. This is x squared times x squared times x squared. That's what the cube means. We write it times itself 3 times. And if we use the rules from last time, this rule right here now applies. We've got x equals 2 plus 2 plus 2 is x to the 6th power. Is there any relationship between the exponents we started with and the exponent we end with? Yes. When we have one exponent and we raise it to another exponent's power, we multiply them. A to the mth power raised to the nth power is a to the m times n power. That's rule B. The next 2 rules are very related, so I'll write them at the same time. So C, we're going to start off with a times b raised to the mth power. You distribute the exponents. This becomes a to the m power, b to the m power. And that also applies when they're divided. A over b to the m power. You can distribute the exponents, a over m and b over m. So maybe I'll call this D and this is C. Notice they have to be multiplied though. These are multiplied, not added or subtracted. It's very important to note. Note. Must be multiplied. Must be multiply or divide. A plus B, if we have a plus sign or a minus sign in there, A plus B, that quantity squared does not equal A squared plus B squared, as we'll see a little bit later on. Okay, make a note of that. No addition or subtraction in there if we're going to distribute the powers. That is a very, very common mistake I see as a math instructor, and it's easily avoided. I just need to emphasize it. Let's take a look at what happens when we've got the same base and we do division. Like here, we got the same base and we multiplied the bases. What if we divide? Let's take a look at that. So my next example I'm going to lead with, let's say we've got 3 to the 5th power over 3 cubed. This is on top, we've got 3 times 3 times 3 times 3 times 3. On the bottom, we've got 3 3s. You following with me so far? All I did is took the base and wrote out the number terms. And now, rather than multiplying and actually doing dividing, since they're all multiplied, I can cancel out common numbers. So I can cancel that 3 with that 3. Remember, it leaves behind a 1. That 3 and that 3. And then I don't have to go from left to right. I could say that 3 and that 3. Anything multiplied by 1 is just the original number. So this ends up being 3 times 3 over 1, which is 3 squared. or 9. And the part I want to emphasize is this. How do those connect? The same, for the similar reasons as multiplying leaded to addition, dividing common bases leads to subtracting exponents. That was effectively 3 to the 5th power over 3 cubed equals 3 to the 5 minus 3, which is 3 squared. The general rule they write it as is a to the m over a to the n equals a to the m minus n. What letter am I on? I'm on E. Let's call that E. And now earlier I told you x to the 0 equals 1. Now I'm set up to prove it. I told you x to the 0 equals x to the 0 power equals 1, or any number to the 0 power equals 1. Let's prove it. And I'm going to start off with having something like this. Let's do x cubed divided by x cubed. Now, one way I can write this is x times x times x and x times x times x, just rewriting the terms without exponents. And if I cancel out common terms on top and bottom, leaving behind a 1, I'm just left with a 1 on top, 1 on bottom, which is 1. If I apply the last thing, now apply E. X cubed over x cubed, they're the same base, we can subtract exponents. This is x to the 0. These two things are identical, which means those two things are identical. X to the 0 equals 1. I used an x because it doesn't matter what the number is. If we have anything to the 0 power equals 1, this can get tricky. For x equals 0, or 0 to the 0 power, and you'll discuss this in calculus. Let's just save the surprise for you. Let's not blow up your brain now. How we doing? Everybody following? Everybody doing good? All right. Let's take a look at the next rule. Again, by example. If I've got, let's just keep the numbers simple. If I've got 2 squared and I divide by 2 cubed, we're doing the same rules as before. I could do this as 2 times, we subtract exponents, and I get 2 to the negative 1. Alternatively, I can write it out. 2 squared is 2 times 2. 2 cubed is 2 times 2 times 2. If I cancel out similar terms on top and bottom, I'm left with 1 over 2. which means 2 to the negative 1 equals 1/2. And that 2 is like having a 1 here. What this shows us is that terms with negative exponents, or I'm going to say values, values with negative exponents can move to the opposite side of the fraction by making the exponent positive. And that gives us two scenarios that come out of this. We have x to the negative n. I can rewrite this as 1 over x to the n. Alternatively, if the negative exponent is on the bottom, I can move it to the top and make it positive. So what is this, f? F? I do want to make a note. I want you to note that exponents only apply to what they're touching. If I have 3x to the negative 1, the negative 1 is only on the x. Only the x can go to the bottom. That's what it equals, not 1 over 3x. The 3 doesn't have the negative exponent. Okay, let's look at some examples, give you something to try. So our first example, we're going to have 2x cubed raised to the 4th power. Try to work that out real quick, and then we'll do it together. Hit pause, please, so I don't have to just sit here and pause for 5 minutes in the videos. Hit pause. Okay, I'm going to assume you did. Recall, like, no exponent is like having an exponent of 1. So that's like 2 to the 1st. And this becomes, remember, when we have an exponent on the outside, the rule says we multiply it on the inside. This becomes 1 times 4 there. And the 3 gets a 3 times 4. The x gets a 3 times 4. And this ends up giving us 2 to the 4th power times x to the 12th power. And 2 to the 4th power, if you work it out, is 16. So this is 16x to the 12th. If we have several polynomials multiplied together, I've got 3x squared and 2x cubed and 4x to the 5th power. They're all in parentheses and I'm multiplying them. I can rewrite this as we can multiply all the coefficients. I'm rewriting the multiplication like such. I can put all the numbers, remember multiplication is commutative. And so I can switch the order around, put all the numbers in front. 3 times 2 is 6. 6 times 4 is 24. And on the x's, I add the exponents, 2 plus 3 plus 5. This becomes 24 times x to the 10th power. So this was multiplying monomials right there. When we multiplying polynomials, here's our rule. Distribute through multiplication. Every term in the first group to every term in the next group. Second, let's write that down. So I really think this is just best by example. Let's give an example. So let's say we've got 7x plus 3, and we're going to multiply it by 4x minus 5. When you distribute through multiplication, try to be systematic with it, or try to be orderly with it. So on part 1, I'm going to do it in 2 parts. I'm going to distribute this one to everything in the first group, or everything into the second group. So I've got 7x times 4x plus 7x times negative 5. And then I'll do a different color for the other one. Then I'll distribute the 3 to everything in the second group, plus 3 times 4x plus 3 times negative 5. Remember, we multiply coefficients separately. 7 times 4 is 28. X times x is x squared. Then I've got 7x times negative 5 is negative 35x. 3 times 4 is 12, and then we've got an x. And then 3 minus 5 times negative 5 is negative 15. And we have a couple, we got some like terms. We combine like terms. We showed doing that before. So these two are alike. We'll combine them. And I've got 28x squared. Negative 35 plus 12 is negative 23 if I subtract it. And then I've got the minus 15. Okay. Now check this out. I just used 2 binomials. This is something we do a lot in algebra, but I want to show you a nice, easy method if there's more terms. If there's more terms, let's do this. Check this out. Pause this page if you need it. And then, you know what? Go big or go home. Let's make our next example hard. Make our next example hard. What I'm going to do, let's multiply x squared plus 4x plus 4. And I'm going to multiply it by x squared minus 5x plus 6. When I have multiple terms like this, not just 2 in each one, I'm going to do that stack approach or stack method. So what I'm going to do is I'll distribute the x squared first to everything over there. X squared, this line, and then I'll just show it like this. X squared, 4x, and 4. This is what happens when I distribute those. X squared times x squared, I add the exponents, I get x to the 4th. X squared times negative 5x, I get negative 5, and then we add the exponents, x cubed. X squared times 6 is just 6x squared. Ooh, maybe I should change up colors. Let's use blue for the single exponent. When I multiply 4x times everything in the second parentheses, 4x times x squared, we add the exponents. 1 plus 2 is 3. I've got 4x cubed. I'm going to stack it underneath the other x cubed. 4x times negative 5x, I get a negative 20. X times x is x squared, so negative 20x squared. And finally, I'll stack that under the x squareds. And 4x times 6 is 24x. I don't have a column with just an x, so I'll make a new one. And finally, we've got, choose the pins that are done first. I got a 4 here. We distribute 4 to everything. We're just multiplying by the coefficient. Coefficient on x squared is 1, so I've got a 4x squared. I'm going to stack that in my x squared column. 4 times negative 5x is negative 20x. We'll put that in the x column. And 4 times 6 is 24. It's a constant. We'll make a new column. When I mean column, where they're stacked on top of each other. Then what I'm going to do is just add vertically. This leads to, there's only one x to the 4th. Negative 5 plus 4 is negative 1. 6 minus 20 is negative 14. Plus 4 is negative 10. Then we've got 24 minus 20 is 4. And finally, 24. I'm going to give you guys an example. I want you guys to, try it now. Your turn. We'll make it a little bit easier. Let's do 4x minus 5. We'll make the second term still be degree 2. Go ahead and work that out, and then we'll do it together. Hit pause, please. All right. I will multiply the 4x through times everything. 4x times 3x squared is 4 times 3 is 12. And x times x squared is x cubed. Then I do 4x times negative 2x. I get an x squared. And 4 times negative 2 is negative 8. And finally, 4x times 7, we just have one x, so it's x. And then 4 times 7 is 28. So 28x. Then I'll distribute the negative 5 to everything in the second one. Negative 5 times 3x squared is negative 15x squared. I'll put it under the other x squared. Negative 5 times negative 2, there's 2 negatives, it becomes positive. And 5 times 2 is 10, so positive 10x. Put that under the other x term. Negative 5 times 7 is negative 35. We'll make a new column for that. We add vertically, we get 12x cubed minus, what is that, 23x squared plus 38x minus 35. Okay, hopefully you got that. If not, go back and see where you made your mistake. Don't just go, oh, I got it wrong, and leave it like that. Try to learn from your mistakes, okay? The best way to learn is to make a mistake and then figure out what you did wrong and learn from it, okay? Very, very powerful. A lot of students don't go back and look at their work and try to fix it. Let's look at a few more examples. And I'm gonna give some formulas for you. I'll show it to you and show you where they come in. Something called difference of squares. You'll see why it's called that in a second. If I start off with a minus b and I multiply it by a plus b, if I distribute, I get a times a is a squared, then a times b is plus ab, and then negative b times a is negative ba, and negative b times b is negative b squared. I can rewrite this though. When things are multiplied, I can change the order. Let's put the a before the b. And now notice these two, ab minus ab, go away. And this simplifies down to a squared minus b squared. This is one square minus another square. Difference is the outcome of subtraction. So that's why they call this difference of squares. You should memorize this. This will help you a lot. Let's take a look at it in operation. If we've got something like 6n or m plus, let's go with 4 times 6m minus 4. This is like a plus b and a minus b, where a equals 6m and b equals 4. If I follow the pattern a squared minus b squared, this should be 6m squared minus 4 squared. And remember, you distribute the 2 to each one. 6 squared is 36, m squared, and then 4 squared is 16. If you don't believe me, you can work it out. We distribute 6m times 6m is 36m squared. Then 6m times negative 4 is minus 24m. Then I do this one, 4 times 6m is plus 24m. And 4 times negative 4 is negative 16. Again, these two cancel each other out, and we get that. So that's the difference of squares. I want you to note it's a little different when you have something that's the same thing. If I have, these are different, it's different than the following. If I have a plus b times a plus b, this is really a plus b squared. That's the short form. If I distribute it out and combine like terms, I get that. And that's why I told you when we have the sum of two, when we have things added and we have the square, we don't just distribute the square. There's more to it. Multiply this out, distribute it out. and you'll see you get that. The other one that shows up, if we've got minus b in there, this is like a minus b squared. And this ends up being a squared minus 2ab plus b squared. So the one that stays negative is the one in the middle. And so let me give you a couple to work on, and I'll show you. This can get pretty tricky. So we'll do one together, then we'll give you one to work on, then we'll do a complicated one, because I want you to see what kind of stuff MathLab will throw at you. They push the bar on that, and it makes testing a little bit easier, I think. So our first example I want you to do, why don't you work out 7y minus 5 and 7y plus 5. Multiply those two polynomials together. Please pause it to do so. Okay. This is like a equals 7y and b equals 5. And this is like a minus b times a plus b. That's a squared minus b squared. This is 7y squared minus 5 squared. Should give you 49y squared minus 25. Okay, a little bit harder. 4x minus 3 plus 7y times 4x minus 3 minus 7y. MathLab will throw shit at you like this, but check this out. What if I've got 4x minus 3 in both? What if I do that? And I've got 7y in both. What if I do that? What if I say a equals 4x minus 3, b equals 7y? Then what I have is 4x minus 3, that's a, I've got an a. And then plus 7y is plus b. And then the other bracket set, 4x minus 3 is a, and negative 7y is negative b. This is a squared minus b squared. So this should give me a squared, which is 4x minus 3 squared, minus b squared, which is minus 7y squared. Okay? They are not going to let you leave it like that, so you have to multiply it out. I really recommend you rewrite this as 4x minus 3 times 4x minus 3. I really don't think those patterns we did right here with the a plus b, and a minus b, I don't think they're that helpful to memorize. I actually think it's just easier to work it out. I can do this one right away. 7 squared is 49, and y squared is y squared. If I distribute here, I've got 4x times 4x is 16x squared. And then 4x times negative 3 is negative 12x. I do the inner ones, that's another negative 12x. And negative 3 times negative 3 is positive 9. I still have my 49y squared negative. And if I combine like terms, 16x squared minus 24x plus 9 minus 49y squared. That's what they're looking for. All right. So far, we've done addition, subtraction, multiplication. We're going to do division next of polynomials. I do want to point out a way they like to remember this real quickly. You may have learned it this way. Let's say we've got 2x plus 1 and x minus 2, and you multiply it out. I do the first ones together. 2x times x is 2x squared. Then I do the outside ones. So I did first. Now I'm doing outside. The outside terms is 2x times -2 is -4x. Then I'll do the two inside ones. So inside, 1 times x is 1x or plus x. And finally, I'll do the last term in each parentheses, last. 1 times -2 is -2. I can still combine like terms. But notice if I call that first terms, outside terms, inside terms, last terms, and I use the first letters, this says FOIL. So when there's two binomials or parentheses with two terms each, you might hear people say FOIL them. It means multiply them out. So they like, that's what they're, when they say FOIL, FOIL is distribute, things like this. Okay, before we do dividing polynomials, I want to just remind you of what basic long division looks like. It's probably been a while since you've done it. So let's see, let's do 6 into 2,275. Don't need to go crazy, but I could literally make this a billion number or a billion in value and keep doing the division. Recall the first thing we try to do, we try to divide the 6 into the first number. It doesn't work. You put a 0 there or skip it. The next thing we try to do is divide the 6 into the next two numbers. I'm actually going to do that. 6 times, I try to divide 6 into 2. It does not go in evenly. I'll put a 0 up there. Take the 0, multiply it by the 6, do it, and subtract it. 2 minus 0 is 2, and bring down the next number, 22. How many times does 6 go into 22 evenly? We got 6, 12, 18, 3 times. 3 times 6 is 18. We subtract. We get a 4. We'll bring down the next number. How many times does 6 go into 47? We've got 6, 12, 18, 24, 30, 36, 42, 7. 7 times. 6 times 7 is 42. We subtract. We've got a 5. We bring down the next one. 6 goes into 55. How many times? It goes in 9 times. 9 times 6 is 54. We subtract. We get 1. So what we have here, the answer here is 379 remainder 1. But in math, we don't say remainder 1. What we do say is we'll say 379, and we'll put the remainder, which is 1, over the divisor outside. 379 over 1/6. Okay? This was 2,275 divided by 6, or 2,275 over 6 equals 379 and 1/6. What did we do? You try to divide it in. Divide in to one number at a time. Put that amount on top, how many times it divides in. Step 1, step 2. Step 3, take that number, take the result, multiply by the number out front. By the divisor, that's what it is. It's what you divide by is the divisor, which is number out front. Step 4, subtract that result. And bring down the next number. And then we repeat until we're out of numbers. That's really what we do with long division. I don't have any variables in it yet. I wanted to show you this, remind you of long division, and it might be a good idea to practice a couple long division problems. Get comfortable with the operation before you start tackling dividing polynomials, because the operations are the same. We follow the exact same scheme. I'm going to show you. Let's take a look at an example. So our example, what we're going to do, we're going to have x squared plus 5x plus 7. I'm going to put it in parentheses because we're dividing all of that, not just the 7, divided by x plus 2. When we rewrite that with the whole division thing, we put this number out front, and we're dividing it into the number in front, or polynomial in front. So what did we do? We tried to see how many times the thing out front divided into the thing on the inside. Just go by the first terms. Go by first terms on division. How many times does x go into x squared? You can easily write this as x squared over x. X squared over x is like x squared over x to the first power. We subtract exponents, we get x. That's what goes up top, x. Then what did we do? We took the number on top and we multiplied it by everything out front and wrote it underneath. So let's do that. X times x is x squared. I'll write it underneath the other x squareds. And x times 2 is positive 2x. So we multiplied that out and then we subtract it. We're subtracting the whole thing. So I'm going to put parentheses right there. And an easier way to do this is literally move the negative inside by changing the sign. I showed you guys doing that before. The x squared turns into negative x squared. And the 2x turns into negative 2x. Let me do this. Let me put it as a plus x squared and then write the negative over it. X squared minus x squared is 0x squared. That's supposed to be what happens. When you move the negative inside, it becomes plus. And then we're adding 5x and negative 2x is 3x. The 0x squared doesn't matter. We can cross it off because it's got a 0. We bring down the next term is a 7. What did we do at this point? We repeated. How many times does the thing on the outside divide on the inside? Let's do it again. So how many times does x go into 3x? Just like I did here, I'm going to do this. I've got 3x over x Well, the x's just cancel. I get 3, right? That goes on top, but it was positive, so we're going to say positive 3. Positive 3 right here, so we have positive 3 right here. We distribute here, plus 3 times x is plus 3x. Plus 3 times 2 is plus 6. Again, I'm going to subtract. And when I move the sign in, I'm going to just make it change the signs. And that turns this into a plus. 3x minus 3x is 0x, which we don't need. We can cross it off. 7 minus 6 is 1. That's the remainder. Remainder of 1 goes over the divisor. So, x squared plus 5x plus 7 divided by x plus 2, that's the problem we started with, equals the result on top and then plus 1 over the remainder, or 1 over the divisor. The divisor was x plus 2, 1 over x plus 2. Okay? Let's do 2 more. Let's make this one a little more complicated. Tell me, are you ready? Are you ready? Let's do it. Eight x to the 4th plus 12x squared plus 7x minus 18 divided by x squared plus 2. And I want to make a note here. Any missing exponent, use a placeholder of 0. So I have 8x to the 4th plus, I don't have an x cubed term, so I'm going to put 0x cubed plus 12x squared plus 7x minus 18. And into that, I'm going to divide x squared plus 0x plus 2. You may not even need the 0x here, but you definitely want the 0x cubed in here because it makes it easier to stack stuff. Let's see what happens when we divide our leading terms, our first terms. So 8x to the 4th divided by x squared. Remember, we subtract exponents and we divide the coefficients. So 8 divided by 1 is 8. And x to the 4th divided by x squared, we subtract. 4 minus 2 is 2, 8x squared. That's what goes on top. I'm now going to distribute that. 8x squared times x squared is positive 8x to the 4th power. 8x squared times 0x squared, 0 times anything is 0. X times x squared is x cubed, so it goes in this column. And 8x squared times 2 is 16x squared. That goes in this column. If you put in the 0 placeholders, it's easier to just stack everything as you do them. Otherwise, it can cause some hiccups. Remember, at this point, we subtract. And I'm going to move that sign in and just change all the signs of everything on the inside. When I combine, the 8x to the 4th goes away. 8x to the 4th minus 8x to the 4th is 0. 0x cubed minus 0x cubed is still 0. 12x squared minus 16x squared is negative 4x squared. And now it looks like I used 3 terms last time, so I'm going to bring it down so I've got 3 terms. And we'll do the process again. Now I'm dividing x squared into negative 4x squared. The x squared cancel and I get negative 4, which I'll put up top. We again take it, multiply. Negative 4 times x squared is negative 4x squared. Negative 4 times 0 is 0x. And negative 4 times 2 is negative 8. We are subtracting that whole thing. So when we subtract it, move the subtraction in and change the sign of what's inside. Negative 4x squared plus 4x squared is 0x squared. That goes away as intended. 7x plus 0x is 7x. And negative 18 plus 8 is negative 10. Now, it looks like we've got stuff left over. What you want to do is stop this process when the degree of what's outside, when the degree or exponent outside is bigger than what's in the remainder. Bigger. If it's equal to, you keep going, but if it's bigger, you stop. Outside the x squared, this is degree 2. It's bigger than inside. The degree is 1, x to the first power. We're going to stop. So 8x to the fourth power plus 12x squared plus 7x minus 18. All that in parentheses divided by x squared plus 2. It equals what we have on top, 8x squared minus 4. And then I'm going to say plus whatever the remainder is, 7x minus 10 over what's outside. And here I won't use the 0x. I'm just going to put x squared plus 2. I think that's good for now. That's R3. I will do R4 next. I'll probably do it tomorrow morning, and you'll have it up Sunday afternoon. I hope everyone's liking the lesson so far. Please remember, you can pause, you can rewind, go over the stuff, make sure you understand, you can follow what I'm doing. If you have any questions, you have my Zoom hours, you can come and show up. You have my text number, you can text me and say, I got some questions, and we can arrange a meeting. I'm your instructor, and I'm here to help you learn, but I can't force you to do it. This is going to take some practice, but I will help you. Peace. Peace. There we go.